We're going to continue topic 7.8, and we're going to be looking about a different type of growth model here. So fish are being introduced to a man-made lake. The change in rate of fish, F, with respect to time is directly proportional to 900 minus F, where T is measured in years, and when T equals 0, there are 400 fish in the lake. 3 years later, there are 600 fish in the lake. Write and solve a differential equation that describes this situation. So the first thing I'm going to do is write my differential. It already talks about F, so I'm going to use dF dt because it said it was proportional to this right here. It's directly proportional. So I know K times 900 minus F is our differential. I'm going to go ahead and separate my variables. So I'm going to bring the 900 minus F to the other side. So I'm going to have to divide dF, and then I'm going to also multiply by dt. I'm going to integrate both sides. I do notice that I need a u substitution here because my u is going to be this part right here. So u equals 900 minus f, meaning that du is equal to negative df, meaning I need a negative here and a negative here in order to use my my u sub. I'm going to go ahead and plug in my u. So I've got that negative hanging out. I know I'm putting in u for the negative 900 f. And then for negative 1 df, I am plugging, that was not the color I wanted, I am plugging in du. When I integrate the left side, I get negative natural log absolute value of u, which I'm just going to plug back in the 900 minus f. And then the right side, when I integrate that, I get kt plus c. All right, now I need to find my initial condition because I need to solve for c and I need to solve for k. So I know that when t equals 0, there's 400 fish in the lake. So I'm going to start with that. So negative natural log absolute value of 900 minus the 400 fish equals k plus 0. I'm sorry. Yes, equals k, I lost something there. Equals k times 0 plus c. There should have been, I totally messed this up down here. It should have been kt plus c. All right, so that goes away. So we get c equals negative natural log of 500. And then my new equation then is negative natural log absolute value of 900 minus f equals kt minus the natural log of 500. Now I'm going to use my other value, the 3 years and the 600 fish, to solve for k. So negative natural log absolute value of 900 minus 600 equals k times 3 minus the natural log of 500. So I get negative natural log absolute value. I could probably drop my absolute values of 300 equals 3k minus the natural log of 500. I'm going to add the 500 to the other side. So I get the natural log of 500 minus the natural log of 300 equals 3k. I know that when I see subtraction in the log world, that becomes division. So I really get the natural log of 500 divided by 300, which is really the natural log of 5/3. And then I'm going to multiply by the 3. So I know that k is the natural 1/3 the natural log of 5/3. So I could rewrite my equation as, I'm going to write it off to the right here. So the natural, or see, I'm going back to the one right before I plugged in. So this one right here. So the negative natural log absolute value of 900 minus f equals 1/3 natural log of 5/3 t, and then minus natural log of 500. Now I'm going to exponentiate both sides, okay? And I'm going to do a couple of, I'm going to exponentiate both sides. But as I'm doing that, I know I got to bring this up as an exponent, and it's going to act really, really weird. It actually it gets multiplied by the t, and they both end up being the exponent on the 5/3. It's just a weird log property. So the natural log negative 900, I'm exponentiating, sorry. Woo, exponentiate. So e to the negative natural log absolute value of 900 minus f equals e to the natural log of 5/3 to the 1/3 t minus the natural log of 500. I need to, let's see what happens. I see what happened. They brought this negative to the other side so they could cancel it. So what they did here is they brought this over. So that's going to become a positive, and then they made this, so it's going to make this exponent a negative 1/3. Okay. All right, so that makes it so we can cancel these. I'm going to go ahead and drop the absolute values off of there because it's never going to get bigger than 900. And then I need to split this into two separate logs. So log of 5/3 to the negative 1/3 t minus the natural e to the negative natural log of 500, which means, when I brought that negative over, it should have switched that to positive. So that's positive. All right, it should have distributed through. All right, I am going to, so right here, it should have been positive. All right, so those cancel. And so we get 900 minus f. These cancel equals 5/3 to the negative 1/3 t times 500. And then I'm going to subtract the 900 over. So we get negative f equals 900 negative 900 plus 500 times 5/3 to the negative 1/3, or negative t over 3. And then I'm going to swap my signs because of the f. So 900 minus 500 times 5/3 to the negative 3, or negative t over 3. So there's my f. So we have the differential now that describes it. Now we get to find the fish population in another 3 years. So we got to be careful because we already know we're 3 years down the line. Another 3 years would mean that our time is equal to 6. I get to just use this equation that we came up with and plug into it. So f of 6 equals 900 minus 500 times 3/5. Wait a minute. What happened? Oh, times 5. It was really 5/3. They did something different with their exponent. Okay, times 5/3 to the negative 6 over 3. And then we're going to put that into our calculator, and we end up with 720 fish when we hit those buttons. Now it wants me to figure out the limit as we approach infinity and explain what the answer means, okay? So I am going to do something fancy over here, which I could have done earlier. Because this is a negative exponent, what it really means is that I could have made a negative exponent on these, and that means I could flip where they're at. So I could have that it was really 900 minus 500 over 3/5 to the t over 3. So I'm going to use that because it might be a little easier to explain this next one. So I'm going to find the limit as t approaches infinity of 900 minus 500 times 3/5 to the t over 3. So when I go to put infinity in here, I know that right, so I know that when I go to put a number in here, it's gonna, no matter what number I put in there, if I make it a big number, it's gonna make the denominator grow bigger. So this would grow bigger than the numerator, meaning that if the denominator is growing bigger than the numerator, that this term here is 0. So I have, and then 500 times 0 would be 0. So 900 minus 0 would be, oops, that is not what I wanted to do. I flipped into something. I totally flipped notebooks, didn't I? There we go. So 900 minus 0 would be 900, would be the limit. So the maximum number of fish, this would be that the maximum number of fish could inhabit the lake would be 900.